So what we're going to do today is we're going to put everything that you learned Wednesday about factoring polynomials to use. We're actually going to use it to solve polynomial equations. So our factoring strategies include using the GCF, difference of squares, some difference of cubes, grouping. We're going to use all of that today. Okay, so before we get into actually how we're going to solve these polynomial equations, we need to talk about a vocabulary word real quick, a term that I'm going to keep using, and that is the degree of the polynomial. So when I think of the degree of the polynomial, I typically just think, what is the highest exponent I see? To be a little more technical though, the definition you have here written down. The degree of a polynomial is the highest degree of the polynomial's terms. So we're going to find the degree of each term by adding the exponents of the variables in each term. Okay, so when I look at this first polynomial, we're going to go term by term and seeing what the exponents of the variables are. So in this first one, my first term has an exponent or degree of 3. Second one has a degree of 2. Third one has a degree of 1. And then my last one has actually a degree of 0. So the degree of the polynomial is the highest degree you see here. So this one is degree 3. For my next polynomial, it's very similar. You can see that the degree of the first term is 1, the degree of the second term is 4, so the degree is the biggest one. So here this is going to be a degree 4 polynomial. So for both of these polynomials, you could just look at the exponents and see what's the biggest exponent, what's the highest exponent, and that's the degree. It gets a little more complicated with examples like this next one, where your terms have 2 different variables. So for these ones, what you have to do, this is when you have to add the exponents of the variables in each term. So the degree of the first term, this is really x to the first and y squared. So the degree of the first term is 3. The degree of the second term is actually also 3 because you have x squared and y to the first. And the degree of the third term is going to be 5, adding that 2 and 3 together. So the degree of this polynomial is actually, this is a degree 5 polynomial. Luckily, we're going to be working mostly with polynomials that look like the first two, where you just have to look at the highest exponent you see. You don't actually have to add them up because there's only one variable per term. So for instance, in our first example here for solving equations, the degree is just the highest exponent you see. It's going to be 4. So this is what we call a degree 4 equation for number 1. So what we're going to do, we're going to keep talking about degree and what that means and what implications that has for each equation. But for now, we're just going to start solving these by factoring. So just like we did with quadratics, we're going to solve these by factoring and then setting them equal to 0. Each of the factors equal to 0. So 0 product property. So let's look at this first one. And you got to think of a way to factor it. So think of everything we used Wednesday, and the way that I'm seeing to factor it is actually difference of perfect squares. So this factors as x squared plus 5 times x squared minus 5. Okay, and then I look and see if I can factor either of those anymore, and I cannot. So I'm just going to go ahead and set each of them equal to 0. Okay, so now we have 2 quadratic equations that we have to solve. But the good news is that you guys are all pros at solving quadratic equations. After last chapter, you can solve any quadratic equation that I put in front of you. So these ones, we can actually just use square root property. So for this first one, I can subtract 5 over, and then I'll take the square root. So I'll get x equals plus or minus, can't forget that. We'll have an I because we have a negative square root, and then square root of 5. Okay. For the next one, I'm going to add 5 over, take the square root again. And this time I'm just going to get plus or minus square root of 5. So here are my solutions. And there's actually 4 of them because I have plus or minus for each one. So I have 4 solutions to this first equation. Okay, so we're going to look at this problem number 2. So problem number 2, again, we're solving by factoring. So you look at the expression, it's set equal to 0. That's good. That's what we need it to be. And then we look, how can we factor that? I see that there's a GCF that we can take out. So we can actually take out 2x. So then I'm left with x squared minus 5x minus 14 on the inside. Can I factor that inside anymore? The answer is yes, I can. So that's a regular quadratic that we can keep factoring. If you want to pause the video and take a moment to try and figure out the factors, please go ahead and do so. They are x minus 7 and x plus 2. Okay. So now what we do, I can't factor anymore, so I'm just going to go ahead and set each of those factors equal to 0. And I can solve these. So this one's just going to be 0 for the first one, 7 for the second one, and negative 2 for the third one. Okay. So this equation is solved. I had 3 solutions. And notice what the degree of the equation was. This was a degree 3 equation. Okay. My next equation is also degree 3. So let's work on solving this one. So, got to think about how to factor it. There's no GCF that I can see. There are 4 terms, so it looks like one of my grouping problems. So I'm going to try to group this one. So in my first group, I have a GCF of 2x squared. I'm left with x minus 5 on the inside. And then my second group, I can take out a 3. Also left with x minus 5. So that's perfect. That means I can group this. All right, so I'm going to take out the x minus 5 then. And then I'm just left with 2x squared plus 3. I cannot factor that anymore, so I'm going to go ahead and set each of those equal to 0 and solve. For the first one, I just have to add 5 over, and there's my solution. The second one is a quadratic again, and we can actually solve it using the square root property. So I'm going to subtract 3, and then I'm going to divide by 2. From here, I need to take the square root. So I will get x equals plus or minus when we take the square root. I will have an I, this will be imaginary. And then I get square root of 3 over square root of 2. So you might remember that we cannot actually leave square roots in the bottom of a fraction. So we have to rationalize. So we need to get rid of that square root of 2. And the way we do that is we multiply the top and bottom by square root of 2. Okay, and what that's going to do, I'll still have my plus or minus I. On the top, I can combine the square root of 3 and square root of 2. I can combine things underneath square roots if they're both underneath. So that will become square root of 6. The bottom would become square root of 4, which is 2. Okay. So here we have 3 solutions. We have one solution and the x equals 5, and then we have 2 solutions, plus I square root of 6 over 2 and minus I square root of 6 over 2. Okay, so we solved that one by grouping. On to example number 4. So this equation is degree 4. Okay, so let's see what happens when we solve this one. So we need to factor it. I notice that there's a factor of 2x that I can take out, and I'm left with x cubed minus 27 on the inside. I asked myself if I can factor this anymore, and I can. This is our difference of cubes, So we're going to have to use that special formula that we learned Wednesday. So if you would like to take a moment to look back and find that formula and try and factor this yourself, you can. It will be x minus 3 and then x squared plus 3x plus 9. Okay. You might remember that when we use a sum or difference of cubes, the quadratic that we get as a factor, that cannot factor anymore. So we're done factoring, so we just set each factor equal to 0. So I'm going to set 2x equal to 0, x minus 3 equal to 0, and then x squared plus 3x plus 9 equal to 0. The first two equations are easy to solve. I just get x equals 0 and x equals 3. This third equation is a little more difficult. I cannot use square root property to solve this quadratic equation because of that 3x term. I can't factor it. I don't want to use completing the square because I have an odd b term. I have a b is 3 here. So we do just need to use the trusty old quadratic formula. So I'm going to plug all my numbers in. That's going to be x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 9 all over 2 times 1. And now we just need to simplify. So 3 squared is 9, 4 times 1 times 9 is 36. So we're going to get negative 3 plus or minus the square root of 9 minus 36 would be negative 27 all over 2. Okay, so now we need to simplify this. We need to figure out first how to simplify that square root of negative 27. So I know that 27 has a perfect square of 9 in it. So I'll take the square root of 9 and that'll be 3i. And then what's left on the inside is going to be 3 all over 2. And I actually cannot simplify that fraction anymore. So we're done. Okay. So notice that we actually have 4 solutions here. We have 0, 3, and then we get 2 solutions right here with that plus or minus. Okay, so what I want you to do now is answer those couple questions to the right of this video before moving on to the next one.